We welcome Dr. Chakravarti Garu, Professor in Department of ECE at Raghu Institute of Technology. He obtained his MTech from Acharya Nagarjuna University and PhD from Department of ECE from JNTUK Kakinada. And he has 18 years of teaching experience, and he is a senior member of IEEE and served as EC member of Vizag Bay section during 2019. He is currently serving as Vice Chairman of Communication Signal Processing Society Joint Chapter. Currently, he is serving 4 research scholars towards their PhD. His research interests include computational electromagnetics and antenna and application of revolutionary computing tools. So, we welcome you to the session. Over to you, sir, please.
Thank you, madam. Good evening, sir. Lakshmi Narayana, sir.
Good evening, Chakravarti Garu. Go ahead.
Yes, sir. So the topic was problem solving using MATLAB. This MATLAB is actually invented by Cleve Moller, the chairman of computer science department at the University of New Mexico. Started developing MATLAB in the late 1970s. He designed it basically for his students who felt the then most popular programming language known as Fortran very difficult to them, and it was actually inaccessible for them to this LinPack and EASPack. Hence, to make the things easy, he developed this MATLAB environment with Fortran as an engine in it and help his students. And soon after that, it started gathering a lot of popularity, and now it is almost equivalent to any other language. And moreover, this MATLAB is basically an interpreter. Now, myself, Dr. Samir, now my interest in this particular topic of problem solving in using MATLAB, I have classified this into two phases. One, I don't want to touch the basics programming techniques of MATLAB. However, I would like to focus on the aspects that are new in MATLAB and that are essential for modern programming, as well as why and little more initial emphasis is on teaching this MATLAB, as well as how this teaching MATLAB has its own environment to emphasize that of a modern classroom. So accordingly, there is a contemporary transformation from the traditional or conventional teaching to a modern classroom teaching. So on the line, I have divided my several topics, listed out several topics that we can discuss. I feel like more potential points that everybody should know about. With a basic knowledge of MATLAB, that is sufficient enough to go through the lecture that we are doing now. And then we quickly have an outline of this MATLAB online. Anyhow, we are not going to deep into this. The MATLAB Drive, MATLAB Mobile, this is more important, and interactive programming with live editor. This is the most essential part of the discussion today. And the other one is MATLAB apps. This is another potential point to be discussed. And the last one is the MATLAB for teachers, where we use a MATLAB grader. So I have with me Dr. Sudhir, who helped me in framing out this PPT. So just I would like to give some credits to him. Going through this contemporary transformation, as I said, there is a definite requirement to shift from traditional and conventional strategy of dealing classroom teaching to a modern classroom teaching. That because the traditional lectures that we usually do with our students in the classroom, they can be nowadays, as due to this pandemic, it is very much evident that they can be replaced by simple videos. That is what we are doing every time for the past many months, since maybe at least June. and moreover it is also impossible for the students to take in and process all the information presented during a typical lecture. That's more important point to be noted, because we teach at the same time there are many graphical and another way of a description that we usually present. However, they cannot be recorded anyhow if they are in the classroom, so there should be some tactical way of handling the situation. So programming is one way where we felt like in the modern era, especially during these lockdown days, transforming all laboratories into mathematical forms, mathematically modeling all the problems in physics, mechanical engineering, as well as electronics and communication engineering, electrical engineering, and then solving these mathematical models using some programming knowledge. So it is almost equivalent to the way we deal in the laboratory. However, it is absolutely not exactly. However, it can be considered that to some extent it is much useful. This way of dealing it, at least we can compensate to one level, because the mathematical modeling plays an important role in engineers life. So coming to this MATLAB Online and MATLAB Drive, these are the two important things. Drive is nothing but a space that is provided by MATLAB. This is a new concept, and MATLAB Online is another new. However, it is not so new to be dealt in 2020, but it was for the past more than a couple of years made it available to the users by the MATLAB. However, it is more available to only those users who have the license or get connected through a license. They can quickly get a user ID generated with the license that they have with us, and then get this license connected to the user ID. And wherever they are, they really don't have to actually take up their laptop with high configuration, because everything will be done on cloud. And the MATLAB environment is something like if they close it at this moment and they can open it at any moment, the same window will be open. That's the beauty of this MATLAB Online. And in this particular case, obviously there is no need of downloading the MATLAB, there is no need of installation, and you can access the latest version, because always the cloud get populated with the latest version, and you are accessing this MATLAB through the through the cloud. And there is no minimum requirement for the system or computing system that you are using. The reason being only one thing, that the only thing that is required is the internet connectivity. If you are firm with the internet connectivity, obvious advantages will be, I mean, the entire burden will be taken care by the cloud and the system that is actually doing all these computations in the cloud. So when the cloud and which is completely managed by the MATLAB. So what you all have to actually take care of is only this part. And coming to the other part, we have it is more prominent and good for teaching, learning, as well as convenient, lightweight access. The reason being very simple, that you don't have to actually ignore the system requirements and other things. That's the most important part. The last one is the 5 GB space for MATLAB drive is also made available, and this drive is something like drive space wherever in cloud you can dump all your MATLAB programs that you are, or your projects or your applications that you have developed in it. Coming to this MATLAB mobile. This MATLAB mobile makes it convenient to learn and teach in disciplines requiring computational thinking, such as math, physics, and engineering. It is just like MATLAB on your mobile. This MATLAB mobile version is made available in to the Android as well as to the iPhone people. However, all the features are power packed in the iPhone version. However, not available completely on Android. But as a professor, you can other examples, or as a teacher, you can other some examples in MATLAB and demonstrate them on your smartphone or tablet simply. Or as a student, you can also allow along on your mobile devices. You can follow them on your mobile devices. You can create, you can edit, you can run scripts, and instantly connect results to the concepts you are learning. When used in and most of the toolboxes in MATLAB, you know very well that MATLAB is completely packed with toolbox, and that is the more potential part and efficiency that makes the MATLAB more efficient. And these toolboxes, they are completely embedded with the MATLAB mobile also. However, if you feel like you see that mathematical equations and some other things, so whenever you get connected, use it with symbolic math toolbox. You can access the functions for disciplines like algebra and calculus. That's possible, which are not generally possible with your simple layman mobile or smart mobile. And you can also perform analytical computations like differentiations, integrations, as well as solving some algebraic and ordinary differential equations. Even this is also possible. You can see on the left side it is Android, the right side it is of course both are iPhone packages only, but however you see the left side version is more typical like an Android, while the right side version you can use. The most important part is the live scripts that we are trying to discuss today. Those are not available with the Android. That makes the difference between the Android and the iPhone package. Now, coming to the most crucial part, the latest innovation in MATLAB is the interactive programming with the live editor. So this makes some sense in teaching, while we can interact with the documents or interact these documents, and you can on the go you can make some changes in the code as well as test them. And repeated coding is also avoided in this particular case. And you can actually accelerate the exploratory program in the sense like you usually come across while mathematical modeling, designing, and some analysis. You do some parametric analysis. The parametrical analysis involves in a particular parameter takes a sweep from lower bound to the upper bound, and you would like to check for each and every value assigned to this parameter and the corresponding output. So that is what usually you try to do in parametric analysis. But in a conventional programming or the conventional editor that is made available till 1516 of this MATLAB, these things with .m file format of programming doesn't allow to, you don't have that freedom actually. You can you have to repeatedly like you have to write a program to get the parametric analysis done, and you can't swing between the values on the go. You have to quickly switch it off, pause your program, pause the running of the program, execution of the program, and then start working on it, and then you have to reinstate. So that's issues with conventional .m files. However, in live editors, the interactive is the interacting with a program and exploratory programming is possible. You can on the go when it is executed, you can change any parameter and test the corresponding output, or you can directly give a sweep of values for a particular parameter and test for each and every test the output for each and every value in that particular array or in a particular matrix. So that is what the live editor is, and interactive because you are directly interacting with the program, and hence it is completely interactive narrative. And besides all these things, you can directly publish the contents. You can all these analysis can be printed, can be converted into a simple HTML file, further into a PDF, and then you can take a print, or you can surf through the entire pages and come to a particular conclusion, or you can do your some analytical treatment on the data that you have at the end for a particular system that you have modeled in MATLAB. So the other most important part is the MATLAB apps. You can see, if you recall earlier, MATLAB has a MATLAB Guide, GUI, the graphical user interface development environment. That MATLAB app is something like you can actually use your push buttons, drop down menus, your radio buttons, and many other things, and you can easily develop a particular applications. an interactive application in fact, and then you can run your program on it. You can change the values, and you can do all these things that are possible within a particular MATLAB app. However, this MATLAB GUI is replaced in the recent version, or in the future versions. It is completely going to eliminate the existing GUI interface and replace it with a new feature known as MATLAB apps, where directly you can make use of all the app templates that are available here. You can see the categorized applications which are already available. The one that comes under machine learning and deep learning, followed by the image processing and the computer vision, because the latest toolbox for the past probably 8 years or 9 years, the machine image processing is completely toolbox is completely removed, and it replaced with the computer vision toolbox. However, all the features are completely intact with the computer vision, or made available in the computer vision toolbox. And under this, you have a camera collaborator, color threshold, DICOM browser, and many other things. So, which means that there are a lot of sensors embedded in it. In fact, so if it is installed on your machine, you can directly use the camera as a sensor, and you can directly take an image, and then you can process that. So if you go back to the MATLAB mobile also, it is the same thing, because your mobile is embedded with a lot many in a good number of sensors and highly sophisticated sensors. You can make use of all these sensors to interact directly with the MATLAB, and MATLAB can fetch the data from all these sensors and process them in the cloud, and then you can analyze them. That's what the beauty of MATLAB mobile and MATLAB apps. And further going further, we have mathematics optimization, and this optimization is a multidisciplinary field which is extending its roots into mechanical engineering, electronics and communication engineering, computer science engineering, and many others, almost all the fields, because this has no boundaries. Because mathematics is a pillar, so optimization is another one. Statistics, which comes under statistical treatment, and also we have these are some set of apps that we have. So, and the last, we have the control system design and analysis, where you have a designer, a tuner, a feature descriptor, a logic designer. So both analog and logical and digital system designers, all these are possible with MATLAB apps. Now, if you look into this, we are talking about basically an LMS integration, learning management system integration. You have a Blackboard, Brightspace, D2L, Canvas, and Moodle. MATLAB Grader integrates with all these things. So it comes out like a button, it's like a added toolbox. No, MATLAB itself is coming out like a added toolbox, an application that can be embedded into any LMS system, any learning management system that you're in. In fact, in Moodle, some people have already tried, and Canvas is something else in which the students were given with some interactive MATLAB interactive work, which they have to code, they have to submit the results, and they are analyzed by a teacher in the Canvas itself. So the teacher doesn't have to actually go out and start working on the MATLAB, or use some other environment to interact with the students with the regarding their work that has been assigned to the students. So this is all possible with the LMS integration. So if you go back to this MATLAB grader, so the traditional grading process goes through the submit homework, get feedback, read it, and it all takes a round clock of nearly 1 to 2 weeks. While here, while dealing with such programming assignments, simply directly the student has the capability, can directly submit his homework, and instant he can get an instant feedback from the teacher, and the teacher can take again the corresponding homework, and the improvements are are monitored, and the process entirely comes under this LMS. So to start with, we have what all it is required is MATLAB 2020 version, the most appropriate one, with all these things that we have discussed till now integrated as a power pack in the MATLAB. So what you have to do is simply go download. No, I mean, actually, you don't have to download the MATLAB. Go to the mathbox.com, create your email ID, connect your college or existing user license to that domain email ID or your account in Mathworks, and then start enjoying this MATLAB Online, MATLAB Drive, Interactive Live Scripts, and MATLAB Reader. So you can actually go through some courses, two important and extremely useful courses on Coursera. One is the Teaching with MATLAB, self-paced course offered by MathWorks directly, and the other one is the Coursera one, exploratory data analysis with MATLAB. However, if you want to go to a low level MATLAB course or a fundamental or basic level MATLAB course, you can directly go through the serial number 4 and serial number 5 MATLAB on RAM by directly the MathWorks itself, and the other one is Introduction to MATLAB. It's a very excellent course available in Coursera for free. And the other high level courses are the first serial number 2 and serial number 3, the exploratory data analysis with MATLAB, and data processing and feature engineering with MATLAB Coursera. So with this, what I do is I would like to switch to my MATLAB environment, and quickly start over working on it. So I think yeah, now I hope you can see my MATLAB window. This big code, piece of code from one serial number 1 to 12 lines of code that is written here, and this environment, this particular window is known as the editor, while under that you have something written as app designer with fx to arrow marks, and this is command window. As I said, MATLAB is basically an interpreter, which means that if I have to assign 2 to x, I can quickly create x and then assign 2 to x. And you can see here in the workspace, this is known as the workspace, where all my variables created in the memory are populated and presented here. And you can see x is quickly created here. Now if I create y is equal to 5, and I have y assigned with 5 in it, and if I want to do x plus y, I can directly go through it, and quickly using a single line command I can do this. By default, if I am not providing any variable into which the results have to be moved, obviously the MATLAB will take care of the result, and it uses the default variable known as ANS, and into that the result will be pushed and it will be presented in the command window. For example, if I am using x is equal to x plus y, you don't find this time the ANS. Z becomes the output. Z is the output. While if I am not giving this Z, then the corresponding ANS, yes, okay, ANS will be defaultly provided by the MATLAB. Okay, so now I would just like to quickly go through one or two examples, because we have some limited time. So what we can do is we can go through some quick examples starting here. As I told you, we are not going to use the basic .m file format. Yeah, .m file format. Rather, what we do is we go through the live script. For that, we go to the top menu, home, new live script, a blank live script. is provided here, and I hope it is visible that you see the entire editor is white in color, while there is at one you can see a strip going on, right? Now here I can actually save this first, my first live script. And you observe this is not .m, this is .mlx. This is .mlx, and this is what my code is, my environment is. Now if I want to create a simple vector v from 1 to 10, let me go to this and execute it. Yeah, you can see v 1 2 3 4, and you see here you don't find the output here in the command window. Okay, this is the more closer console to the live script. And for example, if I try to replace this with some theta values ranging from 0 to 2 star pi, and then I want sine values of this corresponding, then quickly I take sine of theta. Now I start plotting this theta on x-axis and sine values on y-axis, and if I execute this, you can see this. Of course, don't have to blame me, because this is this something looks like a sinusoidal waveform, and obviously the reason being that I did not mention any interval between 0 to 2 pi. For that reason it by default takes 1 as an interval, and if you see theta, it hardly has taken only 7 values. So now what I do is I start 0.001 as an interval. Now this goes more smoother. As you can see this, I am sure you can see this window, right? Yeah, this, and also I can have where is the command window? One second. One second. Yeah, this is the command history. If I don't want, if I have a pre-existing code, or if I have already typed a few commands on it, and I don't want to actually write a MDX file directly, so what I can do is I can directly go here and create a live script right from here itself. It quickly creates a live script from the command history itself. I have a set of commands that I have previously executed, and those set of commands are quickly readily available in my command history. So now those set of commands can have to be transformed into a program, a collected commands forming a program. So what I can directly do is I can select all those programs from all those commands from my command history, and simply go there and generate my live script from there itself. Now if I try to execute this, then I can get the result. So this is another way, and you see it is not always required to save the MLX file without demanding you to save the MLX file. It is executing and giving you the answers like something like an interactive way or interpretive way. That is the beauty of these live scripts. However, if you want to really use this particular live script forever in future, you definitely need to save this as an MLX file. So we will go back here, and the other feature that I want to introduce to you is new section. This is a new section. You can actually, this new section, let us suppose that we use the same thing, but this time I am interested to plot the cost, and for this reason I call these values as cost values. So I want cost, and now you can observe this is a new section, this is another section, and if I want to execute only this three commands, or only this part of my program known as a new section, then I can directly go, need not select this, just put your cursor in this and run the selection. That's it. Now you can see, I'll for the better view I'll close this command window. Yeah, now you can see this, both the first section plot as well as the second section plot, both are preserved. Now actually, there are two ways in which the output can be displayed here. One is output on right, while the other way is output in line. If you click this output in line, you see this section and output, this section and the corresponding output. However, my interest is not that. We can have all the outputs on right side in one place and all my code on the left hand side as one code. Now what I can do is I can run, if I say that run, not the section, not run section, it is run all sections, F5. The default F5, the default run command in my MATLAB. If I do that, then quickly I will be able to generate both the plots. That is what the advantage that we have. Okay, now yes, cost plot, this is sine plot, and this is a simple interactive plot. So what I do over here is I use this once again. Okay, now instead of this 2 pi, I use some x and to assign x with some value like pi or 3.14 for your convenience, 3.14. Now what I can do is I can select this, go to the control, select the numeric slider, and can give a minimum value and a maximum value and the step size and execute this section. This is what I have now. Changing these values will directly impact on the corresponding output. You see that output, the change in the output. It would be more convenient if you look at if you watch out the x-axis. So the x value is between 0 to 1.25 now. X value is having 1.25. So from 0 to 1.25, within an interval, for every interval of 0.01, the theta values are taken, and the corresponding sine values for these theta values are computed and plotted. Now if I try to increase the upper bound of the theta to some 3, let's look at the change in the corresponding output, right? So this is how an interactive way of on the go we can handle any parameter, and that is the reason why I said we are doing some parametric analysis. Now then we'll look into another part, another untitled section here, and we'll throw some light on the if condition. If condition over here. It is not like you don't know what is if condition. Just like out of interest, I am trying to have this if condition loops on this interactive live scripts. However, I am not dealing all. We'll deal a small example of if condition in which we start over with a small statement that it takes input of your age and comments on your age, the MATLAB comments on your age. For this, the input in age is a variable that takes the input, and input of type your age here. And then it's a numeric value, and now the condition starts. If in age is less than 20, it would be interested to comment that you are young. And else, if in age is equal to 40, then it would like to display you are 40. Else, display something if the above three conditions are not met. You are energetic. So we'll run this. However, we have to save this. Age example. Then we run this. Yeah, fortunately there are no errors. Yes, usually we get many errors, and you see this. Yeah, you see this. We have type your age here. So I type my age as 40. Then you look at this part, it is mentioning that it is 40, you are 40, because the first condition failed, so the second condition is satisfied. Then quickly it enters into this. After executing this, it is not going to the next condition or check the next condition. Quickly go to this end and stop this if condition. Now what I try to do now here again is run this. Let us check with the remaining two. Type your age. Now I type that the age is 15. You are young. That's what displayed here. Here. And let us check with the other one. For that we are CLC. Want the command window to be little clean. So type your age here. 25. You are energetic. That's what it's displaying here. Okay. So this is how the if conditions and the other conditions can be quickly understood in MATLAB and can be directly run on live scripts. Sorry. Now, a step ahead, we have to actually discuss many loop statements and other things. However, we are not doing that now. My interest is just to develop an app and show you how the app can be generated. So what you can do is you can directly go to this apps and select design app. Are you able to see this? Go to this left corner, top left corner, check the tab. It's not home plots, it is apps, and under apps you have design app, get more apps, install apps and package apps. We'll see, we'll generate one app and then we'll try to package that app. Then you send it to your friends, they can install that app, and you can also share that app into the cloud. Then anybody can download that particular app. So all these things they can do. For this, what we have done is we have taken a very famous example from the MATLAB itself. It is available in the MATLAB, so we do some little bit of changes in it and then we start working on it. So for this, I'll go to design app. So I think I have to reshare it again. So 1 second, I'm sharing. Let me check. Yeah. So this is now you have seen, right? Yeah. So this is the window that we get quickly as soon as you open. Now I would like to close this. Yes. New blank app. Able to see this? Yeah. Blank app. Yeah, this is the blank screen that I have. Now I would like to have a radio button group, switch. What you can do is you can directly bring this radio button over here. You can rename it male, female, and this can be deleted because it is of not two are sufficient for us. This is the button group, and then I can have a switch. So search for the switch in the left menu. Yes, I have the switch here. So this is a switch. This is used for blood pressure monitoring, and the the corresponding patient's situation and how he is. So blood pressure, BP, it can be cystoid or dialysis. Yes, and then I can have a, a simple push button here, push button here, BP monitoring, or I can say analyze. Then I can also have a data interpreted where I would like to plot the scatter. I would like to have my scatter plot on it. Scatter plot on it. So what I can do over here is I can directly go to this analyze, right? Direct click on it, go to callbacks and add some code to it. Add some code to it. Look at this. Like this, I can have radio buttons, as many radio buttons as required, and I can have a switch from left to right, which has two states, and a push button. Now as soon as I push this button, basing on the condition, is it yes or D, and the corresponding male or female, that particular data has to be populated and plotted along X and Y. And here also what I do is, this is weight versus corresponding patient situation. Now this is the final one. We have weight, we have BP, this is the title given to it, male and female, and cystic or dyscystic. So now this is the code that we have written for the callback. And if you want to look into this code, you can directly go over there, check here. This is the design view, while this is the code view. You have a switch on right top corner of this window where you can switch between the design view and the code view. In the design view, while you have populated earlier, when you, as soon as you put a button over here, sorry, not button, as soon as you put a radio button over here, the names that are assigned to it is button, button 2, button 3, which has been modified to male and female here. So in the code, these two are, the component is button and the name assigned to it is attribute that is assigned to it is male. Similarly, female and button. And similarly, this is a switch, and the name of this switch is BP switch. Okay, so BP switch, and the label is BP switch label, and this is a button. So the name, the corresponding object that is used to control this button or access this button is plot button. So if I change the name over here, the corresponding button will be prefixed with the corresponding name. And this is a UI axis. This is the UI axis. This is the UI axis, right? So this is the piece of code that has been written, where first step here is to write code callbacks, and the corresponding callback is this callback. This is the callback button pushed function, that is plus plot button function, and this function takes two inputs. One is the app and the event. One the complete objects, means these all are accessed and the corresponding events are detected and they are processed. Now before going to plot the data, first of all you have to import the data, you have to load the data. So MATLAB for this particular application and we have several inbuilt databases that are made available to the users for practicing or for some analysis. So we are making use of such inbuilt database, that is patients.mat. So using this load command, you have you have brought in the patients.mat database into your environment, and then from that app.bpswitch.value, basing on this value, the value, see, the component every time has been accessed through this way, this particular command, app default dot the corresponding component, which component, the corresponding BP switch, and the value of it has been accessed. There are two values assigned to this switch, one is SYS and the other one is DSYS, right? So SYS, if it is SYS, the patient is cystotic, and if the corresponding patient is female, then it is checking the button group. So first it is checking whether you have pressed a plot or not. If the plot is pressed, then it is checking this particular button to which it is inclined, switched, S or D. If it is yes, then which one you have selected, the male or female. So basing on this cis yes and male, the corresponding data from the database has been accessed and plotted in the plot that is presented here as a scatter plot. If it is D and female, the corresponding data will be accessed. So that is what we want to do. So similarly, if it is cis, then the X value, Y value, systolic or diastolic. So X value, Y value are taken. If not, if it is male, then the corresponding X value, Y value are taken. So in either cases, it is checking the button and its value. If the button, female button, is true, the value on that means you have switched to you have selected the female button. Okay. Similarly, if this is true, which means if you have selected the male button, then the corresponding data with the gender male have been accessed and stored in X and Y. Then similarly, the same process is repeated if not cis. If it is diastolic, that is D, then this is how you go, the same process, but however this time you don't take the data from systolic, but you take the data from diastolic. So however, all the data finally is populated in X and Y, and you are plotting plotting this X and Y in the UIAXES. So this is code view. So this is coming to our design view. Now you run this. So if I am sure, yes, you don't have it is not shared, right? So I have to unshare it and share it again. Stop sharing and share this pop-up window. This is the pop-up window. Are you able to see this? This is the pop-up window. Once I pressed run, then this is the pop-up window that I got. Now I can switch either ways and say that plot. So for male diastolic, I am plotting. I am trying to populate the scattering plot. So this is how the scattering plot is. And if I select the female and press plot again, Yes, you certainly require a high-end machine, at least 8 GB and 1 TB. It should be at least i5. Otherwise, this highly computation will you will be stuck somewhere. Okay. Now you select mail and select system, and then select hit the plot button. Okay. Okay. So now I close this. Yes, you can see the change. It's taking a lot of time because of lot many things that are currently running on the machine. So if the machine is free and you can also have the graphical interface in it, and NVIDIA, then I think the system can pick up the pace and go accordingly. Okay, anyhow, this is how it is. I just want to demonstrate this. Now what you can do is you can change this small piece of code and start plotting some sinusoidal or uh, cosinusoidal waveform, or you can do some logical plotting by simply replacing this button group with something else like sine and cosine, and for a range of cis means can be 2 pi and cis means can be some pi, lower and upper bound, and then start plotting it. Then the corresponding plot can come. The only get populated in the UI interface over here, in the plot area here. So now I'm closing this. Yes, and now yeah. See, you can go through all these buttons, all the common component library, the container library, component library, the figure 2 component library, instrumentation library, the aerospace library. Lot many things are here, and lot many examples are also available in MATLAB. So now what we do is go to this code view. In the design view, this is the command from where we have actually started replacing the code. You can directly go through it, check the callback functions, go to the callback function, then quickly you will be navigated to this place. Actually there will not be any code over here, only this particular function will be written because you are trying to fix up a callback function over there. So this particular area of code has to be replaced by your own code, and you can write your any logic. The only thing is you have to check with the corresponding button name, or any switch name or any component name from here. If you are not much acquainted with this environment, you can make use of these properties set, which are known as the app components, and then you can make use of all this and access them through app.component. If you are if you want to access VP switch, then how do you access this? By simply app.vp switch. Okay, and if you want to access the button, female button, then how do you access this? App.female button. So any component can be accessed by app dot the corresponding component, and app is here. This is all, right? So this is how the things are very simple. Now we go through some simple examples of MATLAB. Uh, Simple examples related to some signal processing, and then we can close it. However, we would like to show work done by for the purpose of teaching uh, framed by my colleague, my friend Sudhir, making use of that content over here. So I think I have to reshare it. Yeah. Yes. Yeah. Thank you. Now you see here, this is a simple amplitude modulation system. So just let us do this or remove this. You know very well this is message signal. I want to plot the message signal over here. So for representing the message signal, I go directly to the live editor, and I have this particular amplitude modulation program as be modulation demodulation. Actually the modulation content is presented here. This modulation process has been demonstrated, programmed here and demonstrated here. For this particular demonstration, the entire process of modulation has been divided into three sections, where first section will be generating a message signal. In the second section, you will be generating a carrier signal, and in the final section, you will be interested to generate the modulated waveform. Modulated waveform. So let us first of all select this section and execute it. So this is the message signal, right? While this is carrier, this is carrier. We'll execute only this particular section. Let me clear all so that you can understand much better. So run this section. You generate a message signal. Then go to this section, generate a carrier signal. Yeah, this is the carrier signal. So there is a small title. Yeah, this is a carrier signal and there are no errors this time. And this is modulated waveform. This is modulated waveform. So all the three waveforms are here, and all the three codes are written in the same place in the same program, title am2.mlx. Okay, now my interest is to change the corresponding modulation index by simply having a set of am values. For this, I have selected this. Go to control, select the numeric slider, and this numeric slider between 1 to 6, and the step size is 0.1. Good enough. Then look at the final modulated waveform. This is the message signal, this is the carrier signal, and this is the modulated waveform. Now we go over modulation. What is it? This, yeah. Just a second. So you can scroll between any value over here, and the corresponding output be analyzed. Right. So this is how you can do. And for the last time, the last example that I would like to show is this a simple MATLAB file, M file, where I have directly taken an image and tried to perform a DCT using the computer vision toolbox, where this, I'm sorry, using the transformation toolbox that I have in my MATLAB, DCT to the discrete cosine transformation, very much like an FFT. However, there is a difference between these two, but my interest is just to take the DCT of the image that I have taken. So quickly I have taken the image and stored it in a variable RGB in the matrix form, converted it into grayscale, because I'm interested only in the grayscale level. Do some DCT2 on it. Now select those values which are less than 10 and replace them with lower boundary. This is the threshold that I am applying here, and then quickly go to another inverse transformation and show that. Now take the same image once again, but this time select enhance the increase the threshold and start replacing the values, and then take the inverse transformation. Because you have transformed the image into another domain, it has to be brought back to the original domain. So you do the inverse transformation and show the image. So this is just a small example that I have. I am sure you are unable to see the output, right? Yes, yes, because they are pop-outs. So if I try to dock them, yes, all these figures, figure 1, figure 2, figure 3, figure 1, figure 2 and figure 3, you can see the change in the image. Now I think you are able to see, right? Yeah, figure 1, figure 2 and figure 3. So further what you can do is, after this session you can convert this particular transformation also into a live script and replace that thresholding value on a slide bar and keep on sliding and test the corresponding output. That's what you can do. That's like an exercise. And the other one that we have done earlier, prior to this, what you can do is you can change those buttons and start working on your classroom activities or classroom exercises, and develop an application in MATLAB to deal those problems, those classroom problems or exercises. Okay, so that's all for today. So hope we can meet sometime again. Meanwhile, if you are interested, you can push some questions.
Saitya, go ahead.
Yes, sir. Participants, if you have any queries, please post in questions or raise your hand.
Hope to some extent it is useful. Okay. There are two either there are either ways. One, you understood completely, or you are completely left behind what I am saying. There are two ways. So if there are no questions in the chat box, people are very much worried about the feedback. Okay, okay, ma'am. I think that.
Maybe Professor Chakravarti, they are basically
Hmm.
not prepared to ask questions in this forum, in this topic, because
Yes.
most of them may be not using MATLAB. They only trying to start now, right now, after
Okay.
a talk or something like that.
Okay. Okay.
Therefore, they need a little more time to really understand, really acquire, and
Yeah.
really apply this kind of a thing. Therefore, they may not to ask you any questions today.
Yes, sir.
Hope
Yes.
that the feedback form was given,
Yes, sir.
and I hope that Sahitya continue.
So
Yes, sir.
somebody
If
is
there are any
asking for installation link of MATLAB.
Yes, ma'am. The important point is the MATLAB is completely licensed. What you can do is you can log in, provide some credentials. You can prove yourself that you are a student. You can claim a student license from them, and that too for with a limited features and for a limited time. So that you can do. If you are not a student and if you cannot prove that you are a student, then obviously what you have to do is you have to make use of your domain, college domain id. Basing on that, you can create your login and link the license that is provided to you by your college to your email id or to your login, and you are free to use this MATLAB. That is there are two ways. So there is no possibility of MATLAB installation link. You can directly go to mathworks.com and download your MATLAB version, latest version. Mathworks.com.
So if not, with your permission, can I post your mail address so that they can contact you through mail?
Sure, sure, ma'am. Definitely. If there are any questions in the feedback form, also you please direct them to me. We are always available uh, to help them on MATLAB, because like any MATLAB session, this session we have not concentrated on regular MATLAB basics or fundamentals or whatever you call. But this time what we are interested to focus on the latest developments in the MATLAB and latest features that every student and teacher should know and start working on it. So that is the emphasis of this lecture. That's the reason why you can find something new in it in this lecture, definitely. Okay, sure, madam. You can push all the messages to me. I can share my email id also. I hope you have, right?
Yes, sir, we have it. I'm just posting it in the chat box.
Sure.
Okay, we can log off then, Professor Chakravarti.
Okay, sir. Okay. Thank you, sir. Thank you for the opportunity. Thank you, ma'am.
Thank you, sir. Thank you very much on behalf of APSSDC also. Thank you, sir. Thank you very much.